All right, 4.1, chain rule. So essentially, this is taking the derivative of a composite function. Huh?
How much longer do we have in school for exams?
Next week.
Next week are exams?
No, the week after that is exams.
Oh.
Next week is the last week of.
Got it, okay.
Mm.
Yeah, I'm very fearful for my life.
All right, so the chain rule says if f is differentiable
That's what I was getting
at the point u is equal to g of x and g is differentiable at x, then the composite function f of g of x is equal to f of g of x is differentiable
Is that a V? Or U?
where?
The top. At PTV, PTU.
U
U.
is differentiable at x and f of g prime of x is equal to f prime of g of x times g prime of x. In other notation, if y is equal to f of u and u is equal to g of x, then dy dx is equal to dy du times du dx, where dy du is evaluated at u is equal to g of x. Another way to think about it is the outside-inside rule. Which would be y is equal to f of g of x. So dy dx is equal to f prime of g of x times g prime of x. So essentially that's saying take the derivative of the outside piece as a whole, okay, keep the inside stuff together, then multiply it by the derivative of the inside. So if I wanted to find dy dx of the sine of x squared plus 4, I would take the derivative of the outside piece, which is classified as the cosine of everything in parentheses. So, sorry, sine of everything in parentheses. The derivative of sine is cosine. So it would be cosine of, keep everything inside with it, x squared plus 4. Then times the derivative of the inside. So the derivative of x squared plus 4 is 2x. So times 2x is equal to 2x cosine of x squared plus 4. Finding dy dx parametrically. If all three derivatives exist, and dx dt is not equal to 0, then dy dx is equal to dy dt all over dx dt. And then the last note thing here is the power chain rule. Says d dx of u to the n is equal to n u to the n minus 1 du dx.
Is it due to? Or it says if all three derivatives exist?
Dx dt. Huh?
It says 9 minus 1.
Alright, so some examples here. These say to use the given substitution in the chain rule to find dy dx. So it's given to you like this, as y is equal to the sine of 7 minus 5x, and then u is equal to 7 minus 5x. So what you'll notice is that this stuff in parentheses here is u. So we're going to take, to find the derivative, it wants us to find dy du, okay, which is what this is, okay? So we can think about this as the sine of u. And then over here, we're going to also find the derivative of u with respect to x. And then we're going to multiply them together. So right now, they're already splitting it for you. You just need to find the two separate derivatives, if you will, and then multiply them together. In a little bit, they aren't going to tell you what u is. You just have to just see it and know it, okay? So the derivative of sine is what?
Just
Cosine of 7 minus 5x. Okay, whatever's in parentheses, you copy down with it. And then the derivative of 7 minus 5x. Negative 5. So then we lump it all together. So it would be negative 5 cosine of 7 minus 5x is my dy dx. Let's see, 6. Y is equal to 5 times the cotangent of 2 over x, and u is equal to 2 over x. So we're going to find dy du, and then we're going to find du dx. So what is the derivative of cotangent?
sometimes some. No, it's just negative cosecant squared.
Negative cosecant squared. We have the 5 here, so the 5 is going to stay with it. So minus 5 cosecant squared of everything in parentheses, so 2 over x. Then what is the derivative of 2 over x? Okay, or we can think about it as 2x to the negative 1. To the what? To the negative 2. And then we're just going to come out here and we're going to multiply this stuff together. So that's going to be negative 2x to the negative 2 times negative 5 cosecant squared of 2 over x. And then we can simplify this to be 10 over x squared times the cosecant squared of 2 over x, which is our dy dx. All right, number 8. Y is equal to the secant of the tangent of x, and u is tangent of x. So I'm going to find dy du, and then I'm going to find du dx. So the derivative of secant is what? Secant of x, tangent of x, so it's going to be secant of tangent of x times the tangent of x. And the derivative of tangent.
No, it's just secant squared.
Secant squared of x. So then going to multiply this, so that's going to give you secant squared of x times the secant of the tangent of x times the tangent of the tangent of x is your dy dx. Okay, so that's all of the ones where they specifically tell you, here's your function, here's your u value that we're going to find the derivative of after we do the derivative of the outside part. So now it says an object moves along the x-axis, so its position at any time t greater than or equal to 0 is given by x of t is equal to s of t. Find the velocity of the object as a function of t. So that just means take the first derivative.
Can you move it up just so I can see that last, the last thing? Okay, got it.
How far down can I go?
You can go on.
Oh, we're missing something up there.
Yeah.
Okay. All right, so number 10, s is equal to t cosine of pi minus 4t. Okay, so this one is a little weird, okay, because we have a product rule and a chain rule, okay, because it's t times the cosine of all of this. So the chain rule part is going to be here. And then the whole thing is going to give us a product rule. Okay. So ds dt, which is equal to v of t, is going to be the derivative of the first, which is just going to be 1 because the derivative of t is 1, times the cosine of pi minus 4t plus the first t times the derivative of the second. So the derivative of cosine is what? Negative sine of, we copy it down, pi minus 4t. And then that gets multiplied by the derivative of the inside, so it's the derivative of pi minus 4t.
Pi minus 4. No, sorry, just negative 4.
Just negative 4. And that's all getting multiplied. So then I end up with cosine of pi minus 4t minus 4t, or I guess that's going to actually, what is happening? I think it's actually going to end up being a plus. Because that's going to be a negative times a negative, so plus 4t sine of pi minus 4t is going to be that derivative. All right, so then 13 through 24 says to find dy dx. So these are just going to be a whole bunch of different chain rule problems. So 14, y is equal to the cosecant of x plus the cotangent of x to the negative 1. So I've got to imagine everything in parentheses like it's not there right now, okay? Like it's just one variable by itself. So I'm going to take the derivative of the outside parentheses, okay? And then I'm going to take the derivative of the inside. So dy dx is equal to, okay, the derivative of the outside. I'm going to bring the negative 1 out front. I'm going to copy everything down that's in the parentheses as is. So cosecant of x plus cotangent of x. I'm going to subtract 1 from the exponents. That's going to raise that to the negative 2. Then I'm going to multiply it by the derivative of the inside. So the derivative of cosecant of x is what?
Secant squared?
Negative cosecant of x times cotangent of x plus the derivative of cotangent negative cosecant squared of x. So then I'm just going to simplify this as much as possible. So since this is raised to the this parentheses is raised to the negative 2, I'm going to move it to the bottom. Maybe. So that's going to give me, I'm going to leave the negative on top with everything on top. And then move this down. So cosecant of x plus cotangent of x squared. Okay, these negatives are all going to go away because there's a negative on each piece. So when I distribute the negative, it just makes everything positive. And then I have a cosecant in both pieces, so I can pull that out. So that's going to give me cosecant of x times the cotangent of x minus cosecant of x all over cosecant of x plus cotangent of x squared. Because this is a negative exponent. You can't have negative exponents. You got to move them to make them positive. So then this would be your dy dx simplified down. All right, 16. Y is equal to x cubed times 2x minus 5 raised to the 4th. So similar to the one we had earlier, we have a product rule and a chain rule happening here, okay, because I've got stuff in parentheses being raised to a power, and then I've got two things being multiplied. So I'm going to treat this as a product rule and then also a chain rule within that. So dy dx is equal to the derivative of the first, so 3x squared, times the second, so 2x minus 5 to the 4th, plus the first, x cubed, times the derivative of the second, which is going to be, we're going to take the derivative of the parentheses as a whole, and then we're going to multiply it by the inside of the parentheses. So we're going to pull the 4 out front, and then keep the stuff that's inside, subtract 1 from the exponent, and then multiplying it by what's inside. So the derivative of 2x minus 5 is 2. And then I'm just going to rewrite this stuff to simplify it down as much as possible. So this is going to be 3x squared times 2x minus 5 to the 4th plus, let's see, 2 times 4 is 8 times x cubed. So 8x cubed times 2x minus 5 cubed. And if you wanted to do some multiplying around with this, you could, but I'm okay with you just leaving it right there. That's what I was looking at, because the book had a slightly different answer, but that's just because they multiplied it through. All right, so this next one's going to be a little different than ones that we've seen so far. So 18 is y is equal to 4 times the square root of secant of x plus tangent of x. So we need to rewrite the square root in another way so that it gives us something I can work with. What's another way I can write something that's a square root? Just 1/2, but yes. So it's going to be 4 times the secant of x plus the tangent of x to the 1/2. So, got a chain rule. So dy dx is equal to, I'm going to take the derivative of the outside, which is going to be, pull the 1/2 out front. So 1/2 times 4 is just 2 times, copy down the inside, secant of x plus tangent of x. Now I'm subtracting 1 from the exponent, meaning that's going to end up leaving me with negative 1/2 on top, times the derivative of the inside. The derivative of secant of x is,
Secant, isn't it secant x times cotangent of x?
you're close, secant of x times tangent of x.
Just tangent?
Secant of x times tangent of x plus the derivative of tangent of x. Secant squared of x. So then, because this is a negative power, I'm going to move this parentheses to the bottom. I can leave everything else on top. So 2 times the secant of x, tangent of x, plus secant squared of x, all over secant of x plus the tangent of x. Oh, this is to the 1/2. And then if you want to, you can pull out a secant of x. I'd be okay with you leaving it there or going all the way. So 2 secant of x times tangent of x plus secant of x, all over secant of x plus tangent of x to the 1/2. Either thing will work there. Now, your book technically goes one step farther than this. They actually, or you can consider it that they pulled stuff out up here. They take this and they say, since tangent of x plus secant of x is the same as this on the bottom, this is raised to the first power, so they subtract this off. So they get 2 secant of x times the square root of tangent of x plus secant of x. Okay, because 1 minus 1/2 leaves you with 1/2. So they write it this way. Either option is fine. Okay, here or here. Either one I would accept if you did that. It doesn't matter. But just so you know, if your answer doesn't look exactly like the book, it's probably because they went a little bit farther in simplifying or didn't go as far, depending on the problem. Because for some reason, sometimes they do that. Alright, we'll do 2 more for today, and then we'll hold until tomorrow. So 24, y is equal to the square root of the tangent of 5x. So again, this one can be rewritten as y is equal to the tangent of 5x to the 1/2. So then, what would my chain rule give me for this one? Huh? So do the outside of the parentheses. So just pretend this stuff isn't here basically right now.
It's like 1/2.
So this is actually a double chain rule. Okay, so you see you have the outermost chain rule, right? You have the outermost part. Then inside you have the tangent of 5x, which is going to be another chain rule. Okay? So what is the derivative of just tangent of x? Okay? So it's going to be times the secant squared of, we're going to copy down the 5x. Okay? Now that's sort of taking care of that first chunk of the chain rule. Now I need the derivative of the inside, the very inside, so the derivative of 5x is what?
5.
So times 5. So this is kind of a weird one because it's technically a double chain rule, which sometimes will happen. Fortunately, this one wasn't too bad of a double chain rule. Some of them can be a little bit obnoxious, especially if you get them inside of like a quotient rule or something. It's really irritating. But okay, so then this part is moving to the bottom. So on top, I'm left with 5 secant squared of 5x over 2 times the square root of the tangent of 5x. All right, one more, and then I'll give y'all some to do on your own. 26. R is equal to the secant of 2 theta times the tangent of 2 theta. Okay. Now, what's important to remember here is that theta is a variable. Okay. If theta is confusing, feel free to change them to x's. A lot of times halfway through a problem, I will change them because I just get irritated with all the thetas and, well, I just revert back to x's. So if you feel like theta is confusing to you, feel free to switch it to x's. But it doesn't matter to me. So dr d theta is equal to, so I've got a product rule, and then inside of that I've also got the chain rules that are going to happen. So
You always start with the product, right?
yes, because by doing the product rule, when you take the derivative of the first, in doing the derivative of the first, you're going to have a chain rule because of the 2 theta inside. So the derivative of the first, so the derivative of secant is what?
Secant. Secant is tan.
Yep. So it's going to be secant of 2 theta times the tangent of 2 theta times the second, so times, oh, well, hold on. That's not all of the... What is the derivative? I'm just going to throw it out front. What is the derivative of 2 theta? So I'm just going to write the 2 out front for the sake of space. Okay, so I've accounted for the chain rule now in the first half, or the first part of the product rule. So that's the derivative of the first times the second. So I'm just going to write down tangent of 2 theta plus the first, so secant of 2 theta, times the derivative of tangent of 2 theta, which is... Yep, 2 secant squared of theta, or well, of 2 theta. So the 2 is from the outer part, or sorry, the inner part of the chain rule. The outer part gives you the secant squared of 2 theta, and then just write the 2 in front to just, well, kind of sort of save a step, I guess.
And we don't multiply it by 2 at the end.
What do you mean?
Because it's like the tan 2 theta. It's not like...
Technically, this is getting multiplied to this, and this is getting multiplied to this. I'm getting ready to simplify it down as much as possible.
Okay, so we don't do that extra chain where it's like tan 2 theta.
Right here?
Just take the derivative.
This,
Yeah, where we just take the derivative of 2 theta.
we did that. That was what you said by giving me the 2 right here.
Oh, okay, so, okay.
Yeah.
So-
Normally I throw it at the end just so that it's consistent. However, if it's something like that, I'll just go ahead and throw it in front to save a step of moving stuff around. So then I want to simplify this as much as possible. So then since this is being multiplied, this is going to just make tangent of 2 theta squared in the first part. So 2 secant of 2 theta times the tangent squared of 2 theta plus 2 secant cubed of 2 theta. Any questions so far? Okay. So then your problems that I would recommend you try on your own so that you can see how you're doing before we move into ones that are getting more complicated. 1, 9, 19, 25, and 27. We might be able to finish the section tomorrow. It might take us till Friday. Not 100% sure. We'll get through as much as we can tomorrow, and we'll just see what happens. So.